For generations, we were told that the moon is a dead world, a silent companion orbiting Earth, airless, lifeless and inactive, a barren sphere of rock and dust frozen in geological time. Yet the deeper we look, the stranger the moon becomes. For decades, spacecraft have detected mysterious magnetic disturbances hovering above the lunar surface. Not weak signals, not subtle anomalies. In some cases, magnetic fields many times stronger than expected. The puzzle baffled scientists for more than half a century. How could such disturbances exist above a body that possesses no global magnetic field? Where were these signals coming from? And why were they appearing hundreds of kilometers above the surface? A new study proposes an answer. Not aliens, not hidden machinery, not secret lunar bases. Instead, researchers point to an exotic plasma phenomenon known as the Kelvin-Helmholtz Instability. Behind the technical language lies a much bigger story. Because, once again, the culprit appears to be plasma, and plasma changes everything. Space is often described as a vacuum, but that image is misleading. The planets, moons, comets and stars of our solar system do not float through empty nothingness. They move through an ocean of electrically charged particles. This plasma environment is constantly in motion. Streams of particles from the sun sweep across the solar system at hundreds of kilometers per second. These flows interact with planetary atmospheres, magnetic fields, dust and surfaces. Wherever plasma encounters obstacles, surprises follow. The moon offers a remarkable example. Unlike Earth, it lacks a strong global magnetic shield. Solar wind particles can strike the surface directly. Over billions of years, these particles have altered lunar rocks, modified the soil, and electrically charged the fine dust covering the surface. Yet, spacecraft repeatedly detected something unexpected. Localized magnetic disturbances, transient magnetic enhancements, and powerful signatures appearing far above the lunar landscape. Scientists struggled to explain them. Now, a new model suggests that plasma flowing past localized magnetic regions on the moon can generate large-scale waves and vortices. The result? Magnetic fields amplified well beyond what earlier theories predicted. The mathematics may be new. The implication is not. The moon is electrically active. The Kelvin-Helmholtz instability sounds intimidating. The phenomenon itself is not. You can see it on Earth. It appears where two fluids move at different speeds. Clouds sometimes form beautiful rolling wave patterns. Ocean currents create similar structures. The same principle applies in plasma. When streams of charged particles slide past one another, waves develop. Those waves can grow, twist, roll, and evolve into enormous vortices. The new research suggests that such plasma waves may be occurring above localized magnetic regions on the moon. As the solar wind flows past these regions, magnetic structures form and grow. The resulting disturbances may explain the strange magnetic signals that have puzzled scientists for decades. In other words, the moon may be generating plasma weather, not atmospheric weather, but electrical weather. And perhaps we should not be surprised, because electrical activity on the moon has a long history. Long before sophisticated plasma simulations arrived, astronauts were already encountering strange behavior on the lunar surface. Lunar dust became one of the biggest operational problems of the Apollo era. The dust stuck to everything: spacesuits, equipment, windows, instruments. It behaved almost as though it had a mind of its own. The particles are extremely fine and jagged, yet simple mechanics does not fully explain their behavior. Many researchers believe electrostatic charging plays an important role. Sunlight charges the surface. The solar wind charges the surface. Different regions acquire different electrical potentials. Dust particles can become electrically charged and respond accordingly. Some observations even suggest that dust may levitate above the lunar surface. The idea once sounded bizarre. Today, it is taken seriously enough to influence planning for future lunar missions. If dust can be electrically mobilized, then astronauts and equipment may face challenges far greater than originally anticipated. The moon may not simply be dusty, it may be electrically dusty. Then there are the transient lunar phenomena. For centuries, observers have reported unusual lights on the moon. Flashes, glows, bright patches, and temporary colour changes. Many reports are undoubtedly misidentifications. Some are likely observational artifacts, yet not all sightings are easily dismissed. The mystery has persisted. Astronomers continue to debate what causes these events. Possible explanations include gas release, impacts, electrostatic activity, and other poorly understood processes. What matters here is not that every report is genuine. What matters is that the moon has repeatedly shown signs of behaviour inconsistent with the popular image of a perfectly inert world. Something is happening. Whether geological, electrical, or both remains an open question. Even more intriguing are the giant dust structures observed above the lunar surface. These are sometimes described as dust fountains or electrostatic dust transport events. Charged particles may be lifted from the surface and transported to surprisingly high altitudes. Some observations suggest dust can reach tens or even hundreds of kilometers above the moon. To many people, the concept sounds impossible. How can dust rise so high on an airless world? Well, because ordinary wind is not involved, electrical forces may be. Once again, we find ourselves confronting an environment where plasma, dust, electric charge, and magnetic fields interact in ways that remain only partially understood. The moon may not possess weather in the terrestrial sense, yet it appears to possess something analogous. An electrical environment capable of moving matter, generating fields, and producing phenomena once thought impossible. One of the strangest observations from the Apollo era involved the apparent self-cleaning of spacecraft surfaces. Lunar dust quickly became one of the biggest operational headaches faced by astronauts. The fine, abrasive particles clung to suits, instruments, windows, and equipment. Yet some surfaces appeared to shed dust far more readily than expected. What was happening? Simple mechanical explanations have been proposed, but electrical effects may also play a role. The lunar surface is continually exposed to solar radiation and charged particles from the solar wind. Different regions can acquire different electrical potentials, and dust grains themselves may become electrically charged. If electric forces are capable of lifting dust from the surface, might they also redistribute it? Could the moon occasionally give itself a wash? The idea sounds fanciful, yet future lunar missions may depend upon understanding precisely how dust, plasma, and electric charge interact in the harsh environment above it. What makes this latest study particularly interesting is its broader significance. The proposed mechanism may not be unique to the moon. Researchers suggest similar processes could occur on Mars. The red planet presents its own electrical mysteries. Mars experiences some of the largest dust storms in the solar system, with storms sometimes engulfing the entire globe. Dust devils hundreds of meters high routinely sweep across the Martian surface. In the conventional view, these phenomena are driven primarily by atmospheric dynamics. Plasma researchers have suggested an additional factor. On Earth, vast systems of water vapour and clouds can provide an intermediate electrical path between the surface and upper atmosphere. Mars, by contrast, possesses a much thinner atmosphere and lacks extensive cloud systems. As a result, electrical charge may accumulate and dissipate in very different ways. For electrical theorists, giant dust vortices on Mars are therefore not surprising. Wallace Thornhill and others proposed many years ago that dust devils, waterspouts, and even tornadoes may involve electrical discharge processes. In 2005, NASA-backed research investigating dust devils in the Arizona desert found that the vortices carried significant electrical charge. The researchers were surprised to discover strong electric fields associated with the spinning columns of dust, lending support to the idea that electricity may play a larger role in atmospheric phenomena than previously assumed. And why stop at Mars? Plasma fills the solar system. Localized magnetic fields exist throughout planetary environments. Dust interacts with electric charge on multiple worlds. The same fundamental physics may operate across a vast range of scales. Indeed, modern astronomy increasingly reveals a universe threaded by plasma structures, filaments, currents, double layers, instabilities and magnetic vortices. Wherever scientists look, plasma is there, not as a minor detail, not as a footnote, but as a dominant constituent of the visible universe. From the Moon to Mars and from the solar system to the largest structures in the cosmos, the evidence continues to point in the same direction. We live not in a purely gravitational universe, but in a universe where plasma and electromagnetic interactions play a far greater role than once imagined. Present-day plasma activity may be relatively subtle, yet some researchers argue that planets and moons preserve evidence of a far more dramatic electrical past. Across the solar system, we find enormous canyons, crater chains, sinuous rills and unusual surface markings that remain the subject of ongoing debate. While conventional explanations invoke impacts, volcanism and tectonics, plasma researchers have noted intriguing similarities between some planetary features and electrical discharge gas produced in laboratory experiments. The idea remains controversial. Nevertheless, it raises an interesting question. If plasma interactions can generate magnetic disturbances, move dust, and create large-scale vortices today, what might occur during periods of much stronger electrical activity? Viewers familiar with previous Thunderbolts episodes will recognise the broader theme. The Moon, Mars and other planetary bodies may still carry the scars of events far more energetic than anything we witness today. Humanity is preparing to return. Artemis missions promise a new era of exploration. Permanent bases are being discussed. Resource extraction is being planned. The Moon is no longer viewed merely as a destination, it is becoming a stepping stone. But every step forward reveals new challenges. Radiation, dust, electrical charging, plasma interactions, and unexpected magnetic disturbances. The Moon continues to surprise us. The latest research serves as a reminder that even our nearest celestial neighbour remains far from fully understood. For all our confidence, many mysteries remain. For viewers familiar with plasma cosmology, there is a broader lesson here. Again and again, phenomena once attributed purely to gravity or treated as isolated curiosities turn out to involve plasma interactions. This does not automatically validate every alternative theory, nor does it overturn conventional astronomy overnight, but it does highlight a recurring pattern. Electrical processes are often more important than originally assumed, sometimes much more important. The Moon is not merely a passive rock in space. Increasingly, observations reveal a dynamic electrical environment, one filled with charged dust, plasma waves, magnetic disturbances, and phenomena still awaiting explanation. The latest study may solve one lunar mystery, but it raises many others. What role does plasma play in shaping the lunar environment? How significant are electrical charging effects? What mechanisms transport dust across the surface? How do localized magnetic fields influence future missions? And what surprises await astronauts returning to the Moon after more than half a century? One thing is certain, the Moon is becoming more interesting, not less. The old image of a static, inactive world is fading. In its place emerges a far more dynamic picture. A world immersed in plasma. A world shaped by electrical interactions, and a world still keeping many of its secrets. And perhaps that is the greatest lesson of all. The closer we look, the more we discover that the universe is not silent. It crackles, hums, and shimmers with electrical activity. From the sun to the planets, from comets to galaxies, and even on the dusty surface of our nearest neighbour, plasma is everywhere, and the moon is no exception.